Hi, this is a demonstration of KGLac, a data discovery and enrichment platform for data science.
In the last few years, we have noticed the proliferation of datasets, especially with the emergence of data portals which contain a large number of datasets. Such data portals are maintained by governments and organizations as part of open data initiatives or for data science related projects. While the abundance of data is a great asset, it has been widely reported that identifying and preparing relevant datasets takes a very long time in most projects. For this reason, we present KGLac. LaC stands for Lake in French. It is a scalable system composed mainly of GLac construction components and the interface services. The former is responsible for profiling locally stored datasets and generating profiles stored on Elasticsearch, while the latter will leverage these profiles to create GLac, a highly interconnected graph representation where vertices represent data items, datasets, tables, and columns, and their relationships such as content and semantic similarity. In fact, each dataset contains a set of tables, and each table consists of a set of columns. GLac will then be hosted on RDF store to allow data discovery and data enrichment operations via the interface services components. In our demo, we have profiled our locally stored data consisting of 127 datasets covering more than 6,000 columns and generated their profiles to build GLac. GLac will then be hosted on RDF store, on top of which data discovery and data enrichment operations as part of our ML pipeline to investigate compensation bias gap on gender.
Throughout this notebook, I'll use KGLac to explore the gender pay gap by compiling a table containing employee salaries, their genders, and their job domains. I'll first use KGLac keyword search to look for tables containing a column salary, pay, or earning. This result is a pandas data frame that contains table information. I'll load the table with the highest number of rows, which is employee salaries with CSV having around 150,000 records. This table contains employee IDs, their job titles, and the salaries as total pay, which is a good starting point. Using the same KGLac interface to look for tables containing column gender or sex, I found this table named namesGender.csv, but it doesn't have common columns with the previous table. So how can I join them to infer the gender?
To find joinable tables, we can leverage the graph structure of GLac. In fact, KGLac supports searching for a path between our two tables by reporting the intermediate data entities between them. As shown, the result represents a snapshot of GLac.
So this is the salaries table in blue, and this is the gender table in orange, and I can see two paths between them. The first is through the table named employeeinfo.csv, which is part of the same dataset, San Francisco County. This table contains employee IDs and their first names. The employee IDs can be used to join with the salaries table, and the first name can be used to join with the gender table. So the path would be starting from employee salaries.csv, using employee IDs to join with employees info, and then using first name to join with named gender. The other path is a table from another dataset that contains employee salaries, their job titles, and gender. I will return to it later to augment my table with more rows. After loading the employee info.csv table and joining with the gender table, I now have a table of 140,000 rows of employee job titles, salaries, and their genders. I will now load the table that I have found earlier and use it to augment my table with more rows. I need to union this table with the previous one, but I don't know which columns to use.
KGLac helps find the columns you need to union on. You just need to pass the two data frames to KGLac and it will harness their columns to get semantic similarities based on word embedding.
For my task, job titles, gender, and total pay are the most relevant columns. I have used them to union the two tables to get more than 180,000 rows that have salaries, genders, and the job titles. What is left now is to map these job titles to their job domains to know which records belong to the tech industry.
For this, KGLac can help you look for joinable columns that are already materialized in the GLac, the generated knowledge graph. Two joinable columns are columns which have high content similarities by means of their column embeddings. In addition, KGLac supports finding joinable columns with the new data by generating its embedding. This is helpful to discover datasets and enterprises where access to the raw data is restricted.
I see here I have multiple matches. I will load the first table because it looks like it might contain job classification. This looks interesting. I can see there is a job title as well as a job class, which is exactly what I'm looking for. Using native pandas APIs again, I will keep only job titles belonging to the IT class and join it with my salaries table to have records only from the tech industry. With this table of employee salaries and their genders, a data scientist can start exploring the gender pay gap in the tech industry. Thank you very much for listening.